How's it, everybody? Mr. Pat, Hello Boys and Girls Club. Gonna play another song for you. This one is an old Peter, Paul, and Mary or John Denver song based on Leaving on a Jet Plane, which is something a lot of people a little bit leery to do, but people are gonna start doing it. It's a sign of the times. We'll see how that goes. But this is my remixed reflection of it. Okay, ready? My bag is packed, I'm ready to go. Wearing my mask and I pack 3 more. Wash my hands for the 100th time. Dawn is breaking, it's the early morning. My Uber's waiting, can see on my phone. I hope there's no one on this flight of mine. So please blow a kiss for me. Tell me that you'll wait for me. I get back, I'll be quarantined. 'Cause I'm leaving on a jet plane. I don't know when I'll be back again. Well, babe, I hate to go. And that's it right there in a nutshell. Okay, I'm gonna spin this, turn this guitar off. Okay, welcome back to another lesson. It's now Friday. I'm gonna do kind of an enrichment algebra lesson today. Stuff if you took 8th grade math, you did in the previous part of the year. These things are applications with some geometry thrown in. Never a bad thing to practice, always a good thing to practice your algebra. Okay, so thanks for putting up with that music. It's kind of a reflection on what we're going through. Not poking fun, just sharing thoughts. You know, if you're going to fly out, you got to look at quarantine rules where you're going. When you come back, it complicates everything. Will there be people on the flight? Will there be too many people on the flight? All these kinds of things are very impactful. So there's lots of things we're going through. We're going through them together. You never see me wear a mask here because I'm in my room at home. But out and about, if you see me walking my dogs each day, then you know I do wear a mask because I'm wearing that to protect you. Okay, that's what they've proven. It offers me a little protection probably, but mostly to prevent in case I somehow have anything from getting to you folks. That's why we ask you to do the same. Okay, here we go. We're going to jump right into some mathematics. Okay, put that down. So if you're doing this in any kind of notebook configuration, we're doing stuff you, like I said, that you've done before. We've got a couple of different problems here. So this is problem 1, that's problem 2. They're not related. They're separate from each other. So the first one, I know instead of me pausing and waiting for you, if you're doing this at home, you can just pause the video and write everything down and catch up, you know, in your own time. So this is a right angle, the orange thing. You can tell by that little box. So that's a 90-degree angle. That's the takeaway here. And 5x plus 3 is this big angle, and 4x minus 21 is the smaller one down here. Okay, those two together combine to give you your 90. So what you're doing when you're solving stuff like this is you're going angle 1, that's an angle sign, plus angle 2 equals your total. And the reason it's good to get a generic feel for what you're doing, this can change. They might add up to 180, might be 360, might be anything. So we are going to follow this formula with these numbers. So angle 1, we'll just call that the top one. That doesn't really matter. So that's 5x plus 3. There's my angle 1. plus, from that, here's angle 2, that bottom one, 4x minus 21. And this is where you got to pay attention to your problem. It might change the total. This is a right angle, 90 degrees, so it totals up to 90. A lot of students forget to put the equals 90 part. You will be making a big mistake if you do that. So now you're in your combine like terms algebra mode. So there's your equal sign, so everything on the left side gets combined if possible. So like terms are the x terms, same variable, same power, so I'm not getting rid of one of them, I'm combining them because they're both on the left side there. So 5x and 4x is 9x. And then also the 3 and the minus 21. Those are plain old numbers, they're like terms. Either 3 plus negative 21, if you want to think of it that way, or 3 minus 21, that's up to you. You can always go to these and go like that. Means the same thing, you haven't changed anything. So 3 minus 21 is, I can go plus negative 18 or minus 18, either way. But I can't go minus negative 18. So I can do it like that. Or if I'm more comfortable, I can do it like that. And then this is where people fall apart. You got to remember to bring that thing down. Equals 90. So now you're solving a fairly simple equation. So I want the x by itself, so this is subtract 18, so I'm going to add 18. Those cancel, that's what we want. I got 9x, 90 plus 18 is 108. I'm in pretty good shape here. I'm not done yet. I don't want to know what 9x is. I want to know what 1x is. So I divide by 9. Okay, you can come over here and divide 108 by 9. And you see it's 12. So x equals 12. So many times students seem to like half credit, so they stop right there, even with reminders. We want to know how big each angle is. So your teacher stressed this, I'm doing it again right now. Don't stop there. That's the information you need. So it says x equals 12. So wherever you see an x, you got to put 12. So you're going 5 times 12 plus 3. So that's this expression. You're putting a 12 where the x is. So that 60 plus 3 equals 63. That should be one of your angles. So now I go to the bottom one and I still use the 12. Put it where this x is. So you're going 4 times 12 minus 21. And I'm going to erase this so I got a little place to work. So 4 times 12 is 48 minus 21, 27. That should be your other angle. Now, if you're in Mr. Kent's algebra class or Miss Shirk, Miss Parent, Sarsfield, any class, you should be checking to make sure you're right. You can know you're right on this problem. Plug everything in, and then you can go back and see if it's true. So angle 1 plus angle 2 is supposed to equal 90. Gee. So now you know you're right. So these right here in the double box, that's your answer. One angle 63, one's 27. Not particularly hard, but it's good practice that you solve equations, decipher this, remember to finish. right? Okay, so let's move this over a little bit. Look at the next problem. Okay, the next one's different. It says find the area. So you got to know the formula for the area of a triangle. If you don't remember what that is, perimeters add up all the sides. Area is 1/2 base times height. So you have to know what the base and the height are. And you have to remember to multiply those but divide it by 2. Half of it. Okay, so this is a 90-degree angle. So the two things that make that up are the base and the height. The 17 is not the base, it's not the height. So what we have to do is we have to solve for this guy right here. That's the base and height, this one and this one. So you look at that and you go, how are you going to do that? So the good news is it's a right triangle. That's why this is a good problem. It makes you do a couple different things. So first you recognize I need base and height. Those are the ones that make the 90-degree angle, so one of them is missing. So this is a 90-degree angle inside a triangle. It's called a right triangle. So you have to use that. Remember the Greek guy with the long name, Pythagoras? You have to use the Pythagorean theorem. So you have to use the a squared plus b squared equals c squared. And what that's going to do is let you solve for that thing. And then you can go back into your formula and get your answer. So reviewing that, do something here. When you do this, the secret to the Pythagorean theorem is knowing which one is the c, because you got to get that all by itself. There's your equal sign. The c's got to be by itself. So straight across from this is always the c. Remember that. A lot of students forget that. So you don't go 15 squared plus 17 squared. No, no, no. You're trying to find this bugger right here. We'll just call it x for now. So we don't know what x is. That's your a and your b, the ones that make the right angle. That's the c. So there's your a squared plus b squared. There's your c squared. So either multiply on the side, look on your chart your teachers gave you earlier in the year, or just simply use a calculator. And you get x squared plus 225. That's what 15 times 15 is. 17 times 17 is 289. Okay, can't do anything yet. Still got to get x by itself, so we got to get x squared by itself first. So I'm going to minus this away. So now I've got x squared. And what is that? That's 64. Cool. Okay, that is not what we need. X is not 64, folks. So what you're doing is you're taking the square root of both sides. The square root of x squared is x. The square root of 64 is 8. So now I'm good to go. So this bugger right here is this missing side. So now I can go back to my original problem and I can, all my hard work got me what I need, 8 centimeters. Okay? So hopefully you got all that done. You can always go back and look at it. I need a space to work, so I go in like this. Pythagorean theorem is Paul. So now we use what we just learned. So area, whoops, that was good, Mr. Kent. 1/2 base times height. So area is 1/2 times 15 times 8. So there's the base and the height. So I'm going to go like this. 15 times 8, that's 40 and 80, 120. So that's 1/2 times 120. When you multiply by 1/2, that's like dividing by 2. Or just think half of 120 is 60. So my area is 60. Since I have labels, I will finish properly. Area equals 60 square centimeters. Remember, square units for area. Okay, so you use the Pythagorean theorem to solve for a missing side. That's quite common in right triangles, trapezoids, things like that. Sometimes squares and rectangles too. Okay, awesome possum. All right. Okay, we're going to keep going. Got a little more time left energy-wise, so I'm going to go like this. I'm going to keep this split here. Okay. For number 3, solve using substitution. So third quarter you did this. If you haven't had 8th grade yet, pay attention. Pick something up here. It's pretty cool. Okay, so you have what's called a system of equations. All right? And I think I'll go ahead and pick, actually I'm going to pick a complicated one. I'm going to pick one that makes you work a little bit. So y plus 3x equals -7. And x equals 2y plus 14. So that's called a system of equations because there's 2 different equations. And we are using this method. You learn this and you learned elimination. So when you substitute, you put one thing in the place of another. So in order to do substitution, you got to find a variable by itself. You got to work one of these so the variable is by itself. So if you look at the top, it looks like y is by itself, but it's not. You got 3x over here. So you could minus the 3x, but I'm going to do something different. I'm going to look at the bottom one and see how x is by itself. So what we're saying is, wherever you see an x, this is what you write. So x is equal, that means the same thing. X is the same thing as 2y plus 14. So watch what I'm going to do. I'm going to the top equation, but instead of writing 3x, I'm going to put what x equals. So x equals this. So I'm going to put that inside my equation. And then I have to complete equals -7. So here's my top equation rewritten with what x equals substituted in the place of x. Okay, so now hopefully you recognize that it's, you got to do something. Most used property that you get is called the distributive property. When there's a number outside of parentheses, you got to do that. So I'm going to multiply there, and I'm going to multiply there. So the other stuff comes down, we say. So I bring my y down. 3 times 2y is 6y. 3 times 14, what is that? 42. Equals -7. So I distributed my 3 to both of these guys, and that's what I came out with, excuse me. Okay, doing good. All right, 1y plus 6y. Don't forget there's a 1 there. That's 7y plus 42 equals negative 7, combining like terms. I gotta make that 42 go away. Don't divide yet. So 7y equals negative 49. Almost power for this part of it. Okay. Now I gotta divide by 7. And I'm gonna put what I get over here. Y equals negative 7. So that's part of my answer. I took what x by itself, I took what it equals and put it right here in the place of x. That's what this shows. Okay, now I got y equals negative 7, so I got to go back up here and I have to substitute and figure out what x equals. So I'm going to get rid of some of these marks. I'm going to erase this. I got my y value. I need a space to work. So now I go back up to whichever one looks easiest. To me, this looks easiest. So since y is negative 7, I'm going to put a negative 7 wherever the y is. So I go x, I'm working in this equation, equals 2 times negative 7, 2y, plus 14. Okay, so x equals negative 14 plus 14, so x equals 0. Okay, is it right with that? Okay, so that's my other half of this answer. And you might think, oh, I messed up. That's totally okay. That's exactly all right, no problem. So you just found the coordinates, x is 0, y is negative 7. This right here is your answer. If you graphed those two equations on the xy axis, that's the point they cross each other. I promise you, that's what a solution is. Okay, you can check your work. If you've been in my class, you know I'm big on that. So this is your x, this is your y. You don't go into this one anymore. You go back up here. Y is negative 7 plus 3 times 0. Does that equal negative 7? Negative 7 plus nothing is negative 7. Right, you get them right there. That cool? Awesome. Okay. All right. I think we got time for one more. Let's push the envelope a little bit. It's Friday. Okay, this time we're going to use elimination. A lot of people prefer this as a method. We'll see what problem I got dialed up for you. Okay, you ready? Yeah, I'll do an easy one on this. We're kind of been doing this for a while, so I don't want to overwhelm you guys. (6x minus y), 3x plus y. Okay. So when I say easy, elimination works fantastically if the x's are aligned, the y's are aligned, and the numbers and equal signs are aligned. So if all of these are lined up vertically, you're good to go. So sometimes you remember you got to multiply things. You don't even have to do this. You don't get anything by itself. What you're looking for is either x's or y's that cancel each other. So the way you find that is you want things with the same coefficient, that number in the front. And both of these got 1s. And even better, this is -1, that's +1. So -1 plus +1 is 0. So right off the bat, those cancel. I'm adding these equations. And when I do that, those things cancel to nothing. But you can't just do that. You got to add the other stuff. So 6x plus 3x is 9x. Plus 0 is still 9x. And 5 plus 4 is 9. Look how easy that is. A lot of times people prefer this method because it works really good. Not all the time though. Sometimes you got to do a lot of work. Okay, cancel out. X equals 1. So there is half your answer. You are in good shape. Okay. So now we go back up here. I'm going to erase my marks again. I'm going to go back to this top one. This time I'm going to work on this one. X is 1. So 6 times 1 minus y equals 5. Right? Okay, so 6 minus y equals 5. So this is a trick. Check this out. So I'm going to minus 6 from both sides. Now be careful there. So it's a positive 6, so I got a minus 6. That's -1. I did this on purpose. I wanted you to see this again. The answer is not -1. Okay, you could have gone down here and done it also. You could have easily done this on the bottom one. So what I want to show you again is there's a -1 here. We got to get rid of that. So we're going to divide by -1. Remember that tricky kind of thing? A lot of you guys got caught on your equations. So -1 divided by -1, 1 cancels out. So I got my y. -1 divided by -1, 1. That's my y value. So this equation, this system, if you graphed both of these, would cross over at this point. Looks like a happy face. So x is 1, y is 1. Okay, that's just a taste of elimination. Pythagorean theorem, using algebra, substitution. Time well spent. Hope you took the time to do it. That's a good review for you. Some second and third quarter work there. Okay, ready? Okay, that's it. I'm not going to play any more music. I'm just going to say aloha. So you stay safe. It's the weekend coming up. If you are going to go out and do anything, the safer you follow the rules, the better it is for everybody in terms of mask and distance. Your time's going to come soon enough where you can just go give them. For now, use your head, tiptoe back in, and be smart, taking care of each other. Okay, Mr. Pat, hello, Boys and Girls Club. Aloha. See you next week.